Okay, we're still on limits with our 3 cases of limits, just refreshing your memory. You're going to plug in a value and get a number. You're done. That's what would happen. You'd plug in a value and get a number over 0, which means and get 0 over 0, which means do more work. Both of those were in previous sections. And then you have our last case, and that's to plug in the value and get a number over 0. If you get a number over 0, that means it's either going to be infinity, negative infinity, or does not exist. And that also has to deal with the vertical asymptote. Right, so here's a picture, and this is actually in your textbook. I believe that it's on page 66. It's figure 2.26, and that's, of course, if you're using the Briggs book. So on here you have something called a vertical asymptote. Let's change my color. So this vertical line right here is a vertical asymptote. In this case, you have a vertical asymptote at x equals 1. So I want to point out that vertical asymptotes are x equals equations. So that's something you'll need in your quiz. You also have a vertical asymptote here at x equals 3. Okay, so writing something really quickly, vertical asymptotes have x equals equations. In your quiz, I'm going to ask you vertical asymptote questions. If one of the answer choices will say x equals and one of the answer choices will say y equals, so you have to pick the right one. Be very careful. Vertical asymptotes have x equal equations. Just x equals a number. So in this case, you have a vertical asymptote at x equals 1, vertical asymptote at x equals 3. Now, what's special about a vertical asymptote? Okay, first of all, a vertical asymptote occurs where the denominator equals 0. If you have 0 in the bottom, like we talked about on that limit on the previous slide, if you have 0 in the bottom, it's a vertical asymptote. What happens when you have a vertical asymptote graphically is your graph will either go straight up the asymptote, like it does here at 1, or it'll go straight down the asymptote. So at the asymptote, it either goes straight up or straight down. So if you have a number over 0 in a limit, that means your graph either goes straight up or straight down. That does not exist. We'll talk about a little later. But that's why that answer would be straight up, which would be infinity, or straight down, negative infinity. So looking at this particular graph, let me go back to green. I want to know what happens as x approaches 1 from the lower side. That's the left side. So for this particular graph, as x approaches 1 from this side, it's going up. So that means this answer would be infinity. If I looked as x approaches 1 from the right side, that's the 2, 3, 4 side, drawing my graph, I'm going to get as close as I can to 1. It's going up. So that would be infinity. So overall, if I looked at this limit as x approaches 1, I see that they match. They're both going straight up. So both going straight up means that this two-sided limit would also be infinity. Now let's look at the same thing with this 3 here. Okay, I noticed that 3 does have a vertical asymptote there. On the left side of 3, that's this side over here, I know as I'm getting closer and closer and closer and closer to 3 from this direction, it's going down. So this limit from the left side would be down, which is negative infinity. This limit from the right side would be up, which is positive infinity. Now overall at 3, I have to look at what happens from both sides. On the left side it's going down, on the right side it's going up. That means it does not meet. And since it does not meet, that answer is does not exist. This is how infinite limits look on a graph. So I wanted to show you the graph where you'll know why it's infinity. That's because it's going straight up as it approaches that number, or of course why it's negative infinity. So let's look at this one here. I'm asking the limit as x goes to 0. Of course I just plug in to start. So that would be 1 over 0. In my mind, I know that 1 over 0 means that that's going to be an asymptote. So for an asymptote, it's either going up, it's going down, or it doesn't meet. Okay? So what I need to do is I need to know what happens on the left side of 0. I need to know what happens on the right side of 0, and then I can analyze what happens as x goes to 0. Okay, a number on the left side of 0 that I can pick is I can plug in, let's say, -1. Okay, because that's on the left side of 0. If I plug in -1, I get 1 over -1 squared, which would be 1 over 1. The answer to this question is not 1. That will be a multiple choice trick. Don't fall for it. Remember, my answers are either infinity, negative infinity, or does not exist. What this 1 tells you here is that it's positive. That tells me on the left side of 0, it's going up. Okay, so on the left side of 0, this means it would be going to positive infinity. Okay, so now then, let's look at the other side of 0. On the plus side of 0, that would be something like 1. 1 is on that side of 0, so I could plug in 1 into the function. If I plugged in 1, I would get 1 over 1 squared. That would be 1 over 1. Again, the 1 is irrelevant here. What's important is that it's positive. So I would get a positive on this side. So that means on the right side of 0, it would also be positive. So my answer up here is what happens as x approaches 0 from both sides. Since one side goes up, and since the other side goes up, that means they meet. And so my answer would be positive infinity. And that's how you would work it. Okay, let's do one more of these and then I'll change videos. Okay, looking at this next one here, I'm going to plug in the value 4. So when I plug in the value 4, I get 7 over 0. Okay, a number over 0 means it's either positive infinity, negative infinity, or does not exist. So what I need to do is I need to plug in something on the left side of 4. Okay, something on the left side of 4 would be 3. So I'm going to plug in 3 to look at the sign. I don't care the number, I just care about the sign. So if I plug 3 into this function, I get 3 plus 3 over 3 minus 4. So that's 6 over a -1. I don't care that it's 6. What I get out of that is that it's a negative result. Okay? A negative result means that it is going to negative infinity on that side. Okay? I also have to plug in on the right side. So if I plug something in on the right side, I might choose 5. 5 is on the right side of 4, so I will plug in 5. 5 plus 3, 5 minus 4. Okay, I get a positive 8. I don't care about that it's 8. I care about that I get a positive result. So that means on this side of 4, I get positive infinity. Do they match? No. So since they do not match, on the left side it goes down, on the right side it goes up. Your answer is does not exist.